Tonight, as your room sinks into silence and the light from your screen is the only thing left between you and the darkness, there is something turning in the sky that your eyes can never see. Not because it's too faint, but because it's so vast that your entire field of view could never contain it. The human mind evolved to grasp familiar measures: a room, a road, a flight. But try to imagine something so enormous that if you placed our Milky Way inside it, an entire galaxy containing 400 billion stars, the very thing embracing you right now, would suddenly become as small as a grain of sand lost on an endless beach. A lifeless number like 16.3 million light-years isn't enough to shock us. But think about this. If you rode a beam of light and began your journey from one end to the other, you would age 16.3 million years before you could even glimpse the finish line. The greatest is perhaps not a number. The greatest in this universe is when two entirely different truths compete for a single throne, and that is overturning every definition we have ever believed in. For decades, IC 1101 was worshipped as the undisputed king of all galaxies. But what the LOFAR radio telescope recorded from 2022 to 2024 did not just break the old record, it shattered the very way we define the word largest, revealing a structure so vast that scientists had to admit that, theoretically, it should not exist. And throughout the journey ahead, we will go to the very end of a question that seems simplest yet is hardest to answer. Does the largest galaxy truly have only one answer? Or is everything we once believed merely half of an unfinished story? As always, I would love to know where in the world you are listening from and what time it is where you are right now. And don't forget to subscribe to Space Lull to catch the latest videos. For now, let's begin. Here is the first thing you need to know. The answer to the question, what is the largest galaxy, has changed twice in just 3 years, and each change has brought with it a small collapse in how we define the universe. The first change came in 2022, the second, more unexpectedly, in 2024. But to understand why these discoveries are so shocking, you need to start where you're standing. You're inside a galaxy. Perhaps you've never thought about it this way, but right now, as you lie on your bed or recline in your chair, your entire body is enveloped by a disk of gas, dust, and hundreds of billions of stars spinning at 220 kilometers per second. You don't feel that motion, but it is real. The Milky Way, your home, has a diameter of about 100,000 light-years. To visualize that number, think about light. It is so fast that in 1 second, it can circle the Earth nearly 8 times, and even at that unimaginable speed, to travel from one end of the Milky Way to the other, light needs 100,000 years. If you set a countdown clock from the moment light began that journey, by the time it reached its destination, nearly a third of all modern human history would have passed. But the Milky Way, for all its grandeur, is just a drop in the ocean when you expand your view further outward. In the 1990s, when the Hubble Space Telescope began sending back images of unprecedented resolution, astronomers discovered that at the center of a galaxy cluster called Abell 2029, about 1.07 billion light-years away, there was an object whose size made every measure meaningless. That object is IC 1101. Unlike our Milky Way, which is a spiral with bright arms, IC 1101 is a giant elliptical galaxy. It looks like a faint hazy sphere of light, with no clear structure. But that modest appearance conceals an astonishing truth. The entire IC 1101 galaxy, by isophotral measurement, has a diameter of about 550,000 light-years, more than 5 times that of our Milky Way. You could place 5 Milky Ways side by side, end to end, and they still wouldn't be enough to cover a single galaxy. But that is only part of the story. The central core of IC 1101, where the stars are most densely packed, has a radius of about 13,700 light-years, larger than any galactic core ever known, and surrounding it is a vast halo, a cloud of ancient stars, diffusing outward into space with diminishing density, to the point where astronomers still debate how to define its true boundary. According to current estimates, the halo of IC 1101 may extend to about 5.5 to 6 million light-years, 50 to 60 times larger than the Milky Way. It is a number so vast that if you placed our entire galaxy inside that halo, it would be nothing more than a faint speck of dust, lost in an ocean of light. And how many stars does IC 1101 contain? This is where estimates become uncertain. Scientists believe it may hold about 100 trillion stars, roughly 250 times the number of stars in our Milky Way. But remember, this is a number inferred from total brightness and mass, not from direct counting. Because when you look at a galaxy more than 1 billion light-years away, you cannot see individual stars. You only see a faint smudge of light, and from that, astronomers must infer. IC 1101 is primarily composed of old red stars cooler than the Sun, so its brightness is lower relative to its actual mass. The figure of 100 trillion could be an underestimate. Or it could be higher. We don't know for certain. But here is the most important thing. No matter how many stars IC 1101 contains, whether its halo spans 5.5 or 6 million light-years, it held the title of largest galaxy for decades without rival. It was the king, the giant, the monster to which all other galaxies bowed. And as you, right now, lie here listening to these numbers, you may feel a slight sense of overwhelm. That is normal. Your brain was not evolved to process this scale. But I want you to notice one detail. IC 1101 is a king, but the universe, my friend, is not a kingdom. It does not operate by our rules, and in recent years astronomers have begun asking a different kind of question about IC 1101. They no longer ask, how big is it? They have begun to ask, what does big really mean when you change the way you look? Because when you look at IC 1101 with optical eyes, visible light, you see stars. But when you look at the universe with a different kind of eye, a kind of wave that human eyes cannot see, you begin to see things that no one ever imagined. That is when the story changes completely. LOFAR, the low-frequency array, is not a single telescope. It is a network of thousands of radio antennas spread across Europe, from the Netherlands, Germany, Poland, France, the UK, all the way to Latvia and Sweden. Its centre lies in a swampy nature reserve in the Netherlands, a place known as the radio quiet zone, where your phone deliberately loses signal so LOFAR can listen to the faintest whispers from the depths of the universe. It collects radio waves at extremely low frequencies, from 10 MHz to 240 MHz, with wavelengths from 2 to 20 meters. To give you perspective, the FM radio waves you hear in your car have a frequency of about 100 MHz. LOFAR is listening to similar signals, but from objects billions of light-years away. And what LOFAR discovered changed everything. Radio galaxies have been known since the 1950s. Galaxies with supermassive black holes at their centers that are actively feeding. When matter falls into a black hole, a portion is not swallowed but ejected outward as two narrow jets of matter, moving at speeds close to the speed of light. These jets heat surrounding matter until it becomes plasma and glows in radio light. But at low frequencies, the ancient plasma jets, those that have cooled and faded over millions of years, still glow. They are like ghosts of the past, visible only to special ears. While optical telescopes like Hubble only see light emitted by young, hot stars, LOFAR sees the remnants of energy eruptions that occurred long ago. It was in that data, in 2022, that an international research team led by Dutch PhD student Martin Oe found something no one expected. They were processing images from LOFAR, searching for subtle patterns hidden in the data, when they discovered a pair of plasma jets so massive that it haunted their sleep. That structure, which they later named Alcyoneus, has a total length of at least 16.3 million light-years. That number is not an absolute precise measurement, because when viewed from a single vantage point on Earth, you can only measure a portion of the true length. But even the lowest estimate shows that Alcyoneus is equivalent in size to 163 Milky Ways placed side by side. Imagine 163 galaxies, each containing hundreds of billions of stars, lined up in a single row from one end of this structure to the other. For decades, we worshipped IC 1101 as the undisputed king, but IC 1101, with its 5.5 to 6 million light-year halo, is only about 1/3 the size of Alcyoneus. The old king was dethroned by something you cannot see with your eyes, something that only appears when you listen to the universe with a completely different set of ears. The research team named this structure Alcyoneus, after a giant in Greek mythology, a son of Uranos, the primordial sky god. In myth, Alcyoneus fought against Heracles and the gods atop Mount Olympus for supremacy over the universe. Perhaps the scientists sensed the parallel, a giant challenging the old order, a rebel overturning everything we once believed. But Alcyoneus, for all its grandeur, was only the beginning. And what they discovered next, a paradox so profound that it forced astronomers to question their most basic assumptions, was that Alcyoneus's host galaxy, its home, was unexpectedly small. Perhaps the universe is showing us that power does not come from mass, but from the ability to project your influence farther than anyone could ever imagine. This is where the story gets strange. When Martin Oe's research team discovered Alcyoneus, they did what any scientist would do. They investigated its host galaxy. They wanted to know what had created this colossal structure, and what they found left them baffled. Alcyoneus's host galaxy, an elliptical galaxy designated SDSS J081421.68 plus 522410, 0 has a diameter of about 240,000 light-years. That number is roughly 2.4 times larger than the Milky Way, but compared to IC 1101, the old king with its 5.5 million light-year halo, it is merely a speck. Alcyoneus's host galaxy is about 20 times smaller than IC 1101 in diameter. It is not a monster. It is an ordinary galaxy, even somewhat modest. And its stellar mass? About 240 billion solar masses. That number may sound enormous, but in the world of giant radio galaxies, galaxies known for their colossal sizes, it sits at the lower end. According to the study published in Astronomy and Astrophysics, Alcyoneus's stellar mass ranks only at the 25th plus 9% percentile compared to other giant radio galaxies. In other words, 75% of other giant radio galaxies have more stars than it does. Alcyoneus, in terms of matter, is a mediocre galaxy. But what is truly shocking is its black hole. The supermassive black hole at the centre of Alcyoneus is estimated to have a mass of about 400 million solar masses. Again, that number sounds terrifying. 400 million suns is an unimaginable mass. But compare it to IC 1101. The black hole at the centre of IC 1101 is estimated to weigh between 50 and 100 billion solar masses. That means IC 1101's black hole is 125 to 250 times heavier than Alcyoneus's. Alcyoneus's black hole, by percentile, sits at only 23/11% compared to other giant radio galaxies. It is a small, humble, almost mediocre black hole. And here is the paradox. An ordinary galaxy with an ordinary black hole produced the largest structure ever known to be generated by a galaxy. Alcyoneus broke every rule. Let me explain why this matters. For decades, astronomers assumed that the size of a radio galaxy is proportional to the mass of its central black hole. The logic is simple. A larger black hole can accrete more matter, generate more energy, and therefore propel jets further outward. It is a reasonable assumption, and it was confirmed by most observations, until Alcyoneus appeared. Alcyoneus proved that assumption wrong, or at least that it is not the whole story. The researchers wrote in their paper, "Beyond geometry, Alcyoneus and its host are suspiciously ordinary. The total low-frequency luminosity density, stellar mass, and supermassive black hole mass are all lower than, though similar to, those of the medial GRG." They use the phrase suspiciously ordinary, because by every conventional measure, Alcyoneus should not exist. It does not have enough ingredients to produce what it has produced. So what allowed Alcyoneus to become so great? The answer, according to the research team, may lie in its environment, not within it. Alcyoneus resides within a filament of the cosmic web, the largest structure in the universe, a vast network of dark matter, filaments and gas connecting galaxies across hundreds of millions of light years. And within that filament, Alcyoneus may have found something that other giant radio galaxies lack: empty space. Imagine you're trying to throw a ball as far as possible. If you throw it in a room full of obstacles, it will hit walls, bounce back, and stop short. But if you throw it in an open space with nothing in its way, it will travel much farther. Alcyoneus's plasma jets may have encountered a region of extremely low matter density, allowing them to extend farther than any other jets without obstruction. This means that the size of a radio galaxy may not depend on the power of its black hole, but on luck of location. Alcyoneus may have become great not because it was powerful, but because it was in the right place, at the right time, in a region of space empty enough to allow it to reach out far. And if that is true, then there is a deeper implication. There may be many more Alcyoneus out there, waiting to be discovered. We just need to look the right way, in the right places. But Alcyoneus, for all its grandeur, is not the end of the story. Because just 2 years later, in 2024, scientists found something even larger. And this time, it came from a completely different era of the universe. Alcyoneus raised an unavoidable question. If its black hole is too small, and its host galaxy is too ordinary, then what allowed it to become so immense? The answer, according to Martin Owe's research team, may not lie inside Alcyoneus, but outside it, in its surrounding environment, in the very structure of the universe where it resides. To understand this, you need to know about the cosmic web. This is the largest structure in the universe, a vast network of dark matter filaments and gas connecting galaxies to one another, stretching across hundreds of millions of light years. Imagine you are looking at a giant spider web, where the silk threads are dense streams of matter, and the gaps between them are regions of space that are nearly empty. That is the cosmic web. The universe is not uniformly distributed. Matter clusters into filaments, clusters, and superclusters of galaxies, leaving between them immense voids, regions of space with extremely low matter density, where there are almost no galaxies. These voids can span tens of millions of light years, and they play a critical role in the evolution of the universe. And Alcyoneus, according to the researchers, may have been located within one of these voids. The hypothesis is simple. Alcyoneus's plasma jets, streams of matter moving at nearly the speed of light, need a medium to travel through. If that medium is dense with plenty of matter in the way, The jets will be slowed, compressed, and unable to extend far. But if that medium is sparse, nearly empty, then the jets can race forward without much resistance, reaching farther than any other jets. Imagine you're trying to blow a soap bubble. If you blow it in a room full of furniture, it will hit walls, burst, and never grow large. But if you blow it in an open space with nothing in its way, it can become much larger before it pops. Alcyoneus's plasma jets may have encountered such an open space, a void in the cosmic web, allowing them to extend farther than any other jets without obstruction. This resolves the paradox. Alcyoneus does not need a giant black hole to produce a giant structure, it just needs to be in the right place. A place empty enough to allow its jets to fly far. But there is a problem. This hypothesis, while plausible, has not yet been proven. The researchers acknowledge in their paper that they do not yet have enough data to confirm with certainty that Alcyoneus is truly located within a void. They wrote, "If Alcyoneus is located in a low-density environment, that could explain its enormous size." The word "if" is crucial here. This is one of these points where science is still debating. Other researchers argue that the size of a radio galaxy depends not only on environment, but also on the age of the jets. The older the jets, the more time they have to extend further. Alcyoneus may have been active for an extremely long time, tens of millions of years, allowing its jets to travel farther than usual. Or there may be another factor we do not yet understand. But whatever the exact mechanism, Alcyoneus has demonstrated something important. The size of a radio galaxy is not always proportional to the power of its central black hole. Sometimes it depends on external factors, on the galaxy's position in the universe, on the structure of the cosmic web, on luck of location. And that means there could be many more Alcyoneus out there waiting to be discovered. Ordinary galaxies with ordinary black holes, but situated in the right place at the right time, within the voids of the universe, creating structures larger than anyone could have imagined. But Alcyoneus, however grand, is not the end of the story. Because just 2 years later, in 2024, scientists found something even larger. And this time, it came from a completely different era of the universe. Sometimes, the only way to understand the universe is to accept that we may have measured wrong, or at least asked the wrong question. On September 18th, 2024, the journal Nature hit the stands with a cover image that shocked the astronomical community. A pair of colossal plasma jets erupting from a supermassive black hole, extending 23 million light-years into space. It was named Porphyrion, and it shattered every record. The same research team led by Martin Oe discovered Porphyrion in LOFAR data. But this time, they had not just found a giant structure. They had found a structure so large that it raised entirely new questions about the nature of the universe itself. Let us feel this number. 23 million light-years. To give you perspective, if you lined up our Milky Way, the 100,000 light-year-wide galaxy that is embracing you right now, from one end of Porphyrion to the other, you would need 230 galaxies. 230 Milky Ways, each containing hundreds of billions of stars, laid side by side like grains of sand on an endless beach. And even after you had laid them all out, you still would not have reached the end. That number is nearly 10 times the distance between the Milky Way and the Andromeda Galaxy, our two largest galactic neighbours. Alcyoneus, the challenger of 2022, is only 16.3 million light-years long. Porphyrion is nearly 40% longer. It did not just break the record, it crushed the record. But size is not the only thing that makes Porphyrion special. Think about the distance. Porphyrion is 7.5 billion light-years away. The light you are seeing from it left that place when the universe was only 6.3 billion years old, less than half its current age. At that time, the universe was about 10 times denser than today. Galaxies were more active, colliding and merging more frequently. It was a chaotic, turbulent environment. And in that turbulent environment, A black hole ejected a pair of plasma jets, and those jets survived, undestroyed, unobstructed, for hundreds of millions of years, possibly up to 1 billion years. I thought something like this was impossible, said astrophysicist Laura Akaroa Olahalafra-Nieto from the Max Planck Institute for Nuclear Physics, because to sustain a pair of plasma jets 23 million light-years long for 1 billion years, that black hole had to swallow, on average, about 1 solar mass per year for the entire duration, 1 billion years. Each year 1 sun, non-stop without pause. That is persistence beyond belief. And Porphyrion did it. Its name, Porphyrion, comes from Greek mythology, after a giant son of Gaia who fought against the gods on Mount Olympus. In some stories, Porphyrion is the king of the giants. The scientists chose this name deliberately, because if Alcyoneus is a giant, then Porphyrion is their king. But what is truly astonishing about Porphyrion is not just its size or its age. It is what it reveals about the frequency of such structures in the universe. Along with the discovery of Porphyrion, the research team also published a vast catalogue of giant jets. They had found more than 10,000 similar structures, pairs of plasma jets extending beyond 2.3 million light-years, and they had only scanned about 15% of the sky. Let that sink in. 10,000. That is 10,000 systems, each one giant by scientific definition. And that is only what we have seen so far. We were surprised by the existence of Porphyrion, Oy said. Physics shows that jets quickly become unstable. It's surprising that these jets can extend across such a great distance without breaking apart. And the question arises, how? How could a black hole in the early universe, a denser, more chaotic universe, sustain a pair of jets for 1 billion years without interruption? The answer once again may lie in the environment. Like Alcyoneus, Porphyrion appears to be located within a void of the cosmic web. Although the early universe was denser, this particular region had unusually low matter density. When the jets escaped their host galaxy, they pierced through millions of light-years into near-empty space, where nothing stood in their way. And with no resistance, the jets could extend farther than anyone could have imagined. This means Porphyrion and Alcyoneus are not rare exceptions. They may be typical examples of a common phenomenon, a phenomenon we have only begun to recognize because we never before had the tools to see it. And if there are thousands, even tens of thousands of Porphyrions out there, then the question of the largest galaxy becomes more complicated than ever. Because Porphyrion is not a galaxy in the way that IC 1101 is a galaxy. IC 1101 is a vast collection of stars. Porphyrion is a vast collection of plasma, matter heated to the point of breaking apart into charged particles, ejected from a black hole at nearly the speed of light. They are 2 completely different kinds of objects, measured by 2 completely different standards. And that is when our original question, what is the largest galaxy, begins to crumble. Not because the answer has changed, but because the question has become insufficient. What is the largest galaxy? It depends on what you're measuring, and when you change how you measure, you change the answer. But Porphyrion, however grand, is not the end of the story. Because even as nature hit the shelves with Porphyrion on its cover, another discovery was quietly waiting. A structure even larger, discovered only months later, and it would once again challenge everything we thought we knew. So, what was our original question? What is the largest galaxy? We began with IC 1101, a king of stars, with its halo stretching 5.5 to 6 million light-years, containing about 100 trillion stars. A galaxy measured by matter, by mass, by the number of suns that have lived and died within its heart. Then we met Alcyoneus, a plasma structure 16.3 million light-years long, ejected from a black hole residing in an ordinary galaxy. And Porphyrion, 23 million light-years, from a time when the universe was only 6.3 billion years old, and then TXS 0033 plus 252, 26 million light-years, or 8 megaparsecs, also discovered in 2024 from LOFAR data. So who is the winner? The answer, my friend, is both and neither. Because IC 1101 and Alcyoneus, and Porphyrion, and TXS 0033 plus 252 are not the same kind of object. They are measured by completely different standards. IC 1101 is a galaxy in the traditional sense, a vast collection of stars, gas and dust, held together by gravity. Alcyoneus, Porphyrion and TXS 0033 plus 252 are jet systems. Plasma ejected from supermassive black holes, moving at nearly the speed of light and only visible in radiolight. One side is the king of matter, the other is the king of reach, and this is where our definition of largest begins to crumble. Because if you ask an astronomer what is the largest galaxy, they will ask you back, what do you mean by largest? In diameter? In mass? In number of stars? In the size of its jets? There is no single answer, no single throne. Think about this another way. You're asking, who is the greatest? And the answer depends on what you're measuring. The richest, the tallest, the most influential. Those are three different questions with three different answers, and the universe is the same. IC 1101 is still the galaxy with the most stars we know of. It is still the king of matter, the king of mass. But Alcyoneus, Porphyrion and TXS 0033 plus 252 are the kings of space. Structures that reach farther than anything else, drawing colossal lines across the map of the universe. And TXS 0033 plus 252 at 26 million light-years currently holds the record for the largest radio structure ever known. But will it keep that throne? Perhaps not, because LOFAR has only scanned a small portion of the sky. Imagine, you're standing on a beach, picking up a handful of sand and looking at the grains in your hand. You find the most beautiful, the largest grain, and you declare it the most beautiful grain on the entire beach. But you've only looked at a handful. The entire beach is still waiting. That is our position in the universe right now. LOFAR and other radio telescopes are revealing a world we've never seen before. A world of colossal structures, plasma jets stretching tens of millions of light years, ghosts of energy eruptions that occurred billions of years ago. And every time we look deeper, every time we improve our tools, we find something larger, farther, stranger. So the question, what is the largest galaxy? Perhaps it is not a scientific question. It is a philosophical question. It asks us, what are you measuring? And why do you think your measure is the right one? The universe does not care about our titles. It does not hold competitions. It simply exists, vast, complex, and full of surprises. And our task as small creatures trying to understand it is not to assign it titles, but to observe humbly, to listen, and to let it teach us things we have never known. Because every time we think we've found the answer, the universe smiles and offers a new question, but the story is not over. Because while we're talking about records and titles, scientists are continuing to explore, and they are finding things even stranger. When you change the question, you change the answer. And perhaps the most correct question is not what is the largest, but how much do we still not know? We have spent nearly an hour talking about the largest galaxies, but perhaps from the very beginning we've been using the wrong word. Alcyoneus, Porphyrion, TXS 0033 plus 252. These names evoke images of giant galaxies, vast star cities drifting through space. But in reality, they are not galaxies in the sense you still think. They are jet systems, plasma ejected from supermassive black holes, travelling through space at nearly the speed of light and only visible in radiolight. Alcyoneus's host galaxy, SDSSJ 081421.68 plus 522410. 0 is only about 240,000 light-years across. It is an ordinary galaxy, even somewhat modest. But what it produced, the pair of plasma jets 16.3 million light-years long, is a completely different structure. It is not part of the galaxy. It is an extension of the galaxy, a projection of energy out into intergalactic space. Think about this another way. A volcano erupts, lava flows out, forming rivers of red that stretch for kilometers. Do you call those lava flows the volcano? No. You call them volcanic flows. They are products of the volcano, but they are not the volcano. Similarly, Alcyoneus is not a galaxy. It is a jet system, a product of its host galaxy and its central black hole. So why do we call it the largest galaxy? Because we do not have a better word. Because for decades we thought about the universe that way. Galaxies are star cities, and everything else is just detail. But now we are realizing that those details can be larger than the cities themselves. Supermassive black holes, the true protagonists of this story, lie at the center of most large galaxies. In our Milky Way there is a black hole named Sagittarius Asterisk. With a mass of about 4 million suns, it is sleeping, not ejecting giant plasma jets. But in some galaxies the black hole is active. It is swallowing matter, and in that process it generates energy, and that energy is released in the form of jets. Alcyoneus's black hole weighs only about 400 million suns, a modest number compared to IC 1101's black hole, which may weigh up to 100 billion suns. But that small black hole produced a structure larger than anything the giant black hole of IC 1101 ever produced. That means the power of a black hole is not only in its mass, it is in how it interacts with its environment. It is in its position in the cosmic web. It is in luck of location. And this is where the story becomes truly interesting. Because if the black hole is the protagonist, then we are living in a universe where small, humble protagonists can create influences larger than anyone could imagine. Think about that. A black hole with a mass of 400 million suns, an object with a diameter of only about 2.4 billion kilometers, smaller than the orbit of Saturn, created a structure 16.3 million light-years long. The ratio between the size of the black hole and the size of the jet is about 1 in 10 circumflex 14, 1 part in a million billion. That is the power of gravity when released in the right way. That is the power of a small object capable of reshaping the structure of space around it on the largest imaginable scale. And that raises a profound question. If a small black hole can create such a large structure, how many other black holes are doing the same thing that we have not seen? Because LOFAR has only scanned a small portion of the sky, and in that small portion it has found more than 10,000 giant jet systems. Imagine what is waiting in the rest of the sky. Perhaps the question, what is the largest galaxy, is obsolete. The more correct question is, what is the largest jet system, and what is it telling us about how the universe operates? Because every time we find a new structure, every time we discover a longer, farther jet, we learn something new about how black holes interact with their environments. We learn that the universe is not just static galaxies, but a dynamic energy network where small objects can create colossal influences. And perhaps the most astonishing thing is not the size of these structures, but the fact that we, small creatures on a small planet, have been able to see them, measure them, and begin to understand them. We are living in an age where the boundaries of knowledge are being pushed back every day. And every time we think we have found the final boundary, the universe opens a new door. Black holes are not just engines of destruction. They're engines of creation. They create jets, and those jets reshape the space around them, influence the formation of stars, and perhaps even influence the evolution of the galaxies themselves. And we, here tonight, are beginning to understand that. Just months after Porphyrion shook the astronomical community with its 23 million light-years, another contender silently ascended the throne. TXS 033 plus 252. A dry name devoid of any poetry, not Alcyoneus, not Porphyrion, names that evoke the giants of Greek mythology. just a lifeless astronomical designation. But behind that name lies a structure even larger than all we have just beheld. TXS 0033 plus 252 has a total length estimated at about 26.04 million light-years. That is 8 megaparsecs, a number astronomers use to measure cosmic distances far beyond human comprehension. If you lined up 260 Milky Ways side by side, you would have a row equivalent to the length of this structure, and it is not just larger than Porphyrion. It is 1.5 times larger than Alcyoneus. If you placed Alcyoneus next to TXS 0033 plus 252, Alcyoneus would be only about 60% the size of the new giant. But there is a detail that makes TXS 0033 plus 252 more special than anything we have seen before. Unlike Alcyoneus and Porphyrion, which were found in voids of the cosmic web, TXS 0033 plus 252 lies in a different location. It is classified as a field galaxy, a galaxy that does not belong to any cluster. It is alone. It drifts by itself in the space between large structures, with no neighbouring galaxies extending their gravitational pull upon it. And its host galaxy, surprisingly small. It has a diameter of only about 48,700 light-years, less than half of our Milky Way. If you placed this tiny galaxy next to IC 1101, it would be a tiny speck, nearly invisible in the giant halo of the Old King. Its stellar mass is about 195 billion solar masses, a modest number compared to IC 1101. So how could a small, isolated galaxy produce the largest radio structure ever known? The answer may lie in that very isolation. As a field galaxy, TXS 0033 plus 252 is not affected by the gravitational pull of neighbouring galaxies. No collisions, no disturbances, no streams of matter swirling in to disrupt its jets. It can sustain its activity for longer, more stable periods, allowing the plasma jets to reach farther. The distance from TXS 0033 plus 252 to US is about 5.94 billion light-years, slightly closer than Porphyrion, but still in a distant epoch of the universe. The light that LOFAR received from it left that place when the universe was only about 7.8 billion years old. But what is remarkable is that, although the universe was denser then, TXS 0033 plus 252 was still able to reach farther than any other structure. And here is what truly baffles scientists. TXS 0033 plus 252 was discovered from the LOFAR 2-meter sky survey LOTES-S data, the same survey that found Porphyrion and Alcyoneus, meaning all these discoveries came from the same dataset, and that dataset has only covered about 15% of the northern sky. Let me emphasize that. 15%. We have only looked at 15% of the sky, and we have found 3 structures that surpass every previous record, each larger than the last. Alcyoneus in 2022, Porphyrion in 2024, TXS 0033 plus 252 also in 2024. 3 discoveries, 3 records, in just 3 years, from the same survey, from the same small fraction of the sky. So what about the remaining 85% of the sky? How many Alcyoneus, how many Porphyrion, how many TXS 0033 plus 252 are waiting there? Perhaps the most terrifying thing is not what we have found, but what we have not yet found. TXS 0033 plus 252 surpassed Porphyrion to become the largest known radio galaxy as of 2024. But that title, as we've seen, may not last long, because every time LOFAR or another telescope scans deeper into the sky, they find something larger. And with the Square Kilometre Array, SKA, about to come online, we stand at the threshold of a new revolution in exploring the universe. But before we look to the future, let us pause for a moment and reflect on what we have learned. When you started this video, you thought there was a simple answer to the question, what is the largest galaxy? IC 1101. That was what you were taught. But now you have seen that the answer is not simple at all. It depends on how you measure. It depends on whether you're looking at matter or influence. It depends on whether you're using your eyes or your ears. And perhaps, The most astonishing thing is that we, small creatures on a small planet, have been able to see all of this. We have built tools to listen to the universe in ways our ancestors could never have imagined, and every time we listen, the universe whispers a new secret. But TXS 033 plus 252, however grand, is not the end of the story. Because while scientists are analysing data from LOFAR, a new era is approaching, an era where we will be able to see deeper, farther, and perhaps find things even stranger. When you change the tool, you change the universe. And we are about to change our tool. TXS 0033 plus 252 held the record for the largest radio structure ever known. But the important thing to remember is that is only what we have found so far. Think about this. The LOFAR 2-meter sky survey, the survey that discovered Alcyoneus, Porphyrion and TXS 0033 plus 252, has only covered about 15% of the northern sky, and in that 15%, it has produced a giant radio catalogue containing 4,396,228 sources, more than 4 million objects emitting radio waves in just a small fraction of the sky, and among them, scientists have identified more than 26,000 radio galaxies and over 2,000 quasars. Thousands of galaxies are speaking to us through radio waves, and we have only just begun to listen. But what is truly astonishing is that what is being discovered does not stop at size. In June 2026, an international research team, working with citizen scientists from the ARAD at Home Astronomy Collaboratory in India, announced a discovery so strange that it left astronomers stunned. They had found a radio galaxy with a shape never seen before, a giant bow and arrow-like structure with an arc nearly 1.8 million light-years across. It was named Rad-Barg, Bow and Arrow Radio Galaxy. The morphology of this source does not resemble any radio galaxy I have seen in 25 years, said Dr. Ananda Hota, the head of the research team. Its remarkable morphology appears to show signs of interaction between relativistic radioplasma and a large-scale shock generated during the galaxy's infall into a nearby galaxy cluster. Imagine a supersonic aircraft. When it surpasses the speed of sound, it creates a shockwave, a sonic boom. Rad-Barg is doing the same thing, but on a cosmic scale. Its host galaxy is plunging down at supersonic speeds through the surrounding hot gas, creating a colossal shockwave, and the radioplasma from the central black hole has illuminated this otherwise extremely faint structure, making it visible in LOFAR's low-frequency images. This means LOFAR is not just helping us find the largest structures, it is also helping us see physical phenomena never observed before. Cosmic shock waves, interactions between galaxies and their environments, dynamic processes shaping the universe in ways we never imagined. And Rad-Barg is just one example. Scientists have built a sample of 111 double-giant radio galaxies, systems that have undergone multiple sequential episodes of activity. These discoveries are changing how we understand black holes operate, how they interact with their surroundings, and how they can sustain activity for millions of years. But here is what is truly shocking. All these discoveries, Alcyoneus, Porphyrion, TXS 0033 plus 252, Rad-Barg, thousands of other giant radio galaxies, all came from the same survey, the LOFAR 2-meter sky survey. And that survey is still ongoing. We have only looked at a small portion of the sky. We have only begun to understand what is out there. So how many more Alcyoneus are waiting to be discovered? How many more Porphyrion? How many more TXS 0033 plus 252? And how many more Rad-Barg? Strange, unprecedented structures challenging all our classifications. The answer is, we do not know. And that is what makes it most exciting. Because every time we think we have understood the universe, it shows us something new. Every time we think we have found the final boundary, that boundary is pushed further, and every time we think we have the answer, the question changes. But the story is not over, because while LOFAR continues scanning the sky, a new tool is being built, one that will be many times more powerful than LOFAR, and will open a completely new door into the universe. And when that door opens, what we find may change everything once again. Perhaps the most astonishing thing is not what we've found, but what we are about to find. February 2026. An event took place that few outside the astronomical community noticed, but it would change how we see the universe forever. An international research team, led by Dr. Timothy Shimwell from Astron in the Netherlands, published the largest and most detailed radio map ever created in human history. It was LOTS DR3, the LOFAR 2-meter sky survey data release 3, the result of over a decade of observations, data processing, and scientific analysis. The number that stunned the scientific world: 13.7 million radio sources, 13,700,000 objects emitting radio waves, each telling its own story about the universe. This is the most comprehensive inventory ever made of supermassive black holes in their active growth phase. Each of those 13.7 million sources is a hole in space, a black hole swallowing matter and ejecting energy in the form of giant plasma jets. To create this map, scientists had to process 13,000 hours of observations. The sheer volume of data, 18.6 petabytes, equivalent to about 4.7 million HD movies. And to process that volume of data, they used over 20 million computing hours on supercomputers across Europe, with the Jewels supercomputer at the Jülich Supercomputing Center in Germany playing a crucial role. LOFAR, the tool that created this map, is not a single telescope. It is a network of 52 stations spread across 8 European countries, linked over distances of up to 2,000 kilometers. 38 stations in the Netherlands and 14 international stations work together as a single telescope the size of Europe. It observes at low radio frequencies, a wavelength range that reveals high-energy processes in the universe that optical telescopes cannot see: giant jets from black holes, galaxies in intense star formation, merging galaxy clusters, faint supernova remnants. The challenge was first and foremost mathematical and computational on an extraordinary scale, said Cyril Tasser, a researcher at the Paris Observatory. We had to deepen the theoretical understanding of low-frequency interferometric imaging before we could translate it into powerful algorithms capable of handling such massive data volumes. And what this map reveals is astonishing. It allows scientists to study populations of supermassive black holes at different evolutionary stages, showing that their characteristics depend not only on the black hole itself, but also on the host galaxy and the surrounding environment. It also reveals that giant shocks and turbulence are driving particle acceleration and amplifying magnetic fields on scales of millions of light years. And this happens far more often than previously predicted. Among those 13.7 million sources, scientists have identified some of the largest and most ancient radio galaxies ever known. It was from this map that Alcyonius, Porphyrion, and TXS 0,033 plus 252 were discovered. And it continues to reveal new secrets, from interactions between stars and exoplanets to variable and transient objects that scientists still cannot classify. This giant map is the result of over a decade of coordinated observations and analysis on an international scale, Timothy Shimwell said. It provides an unprecedented statistical view of active galaxies and galaxy clusters, and has been changing our understanding of the evolution of cosmic structures. And the most astonishing thing, LOTS DR3 covers 88% of the northern sky, but LOFAR has not stopped. Since 2024, LOFAR has been organised as a European research infrastructure and is being upgraded to the successor system, LOFAR 2.0, expected to double the sky survey speed and provide significantly higher angular resolution. If LOTS 3 revealed 13.7 million sources, LOFAR 2.0 will find even more. And combined with what is happening in the Southern Hemisphere, where Meerkat is quietly making its own discoveries, we stand at the dawn of a new era of radio astronomy. While LOFAR dominates the northern sky, another telescope in the Southern Hemisphere is quietly making discoveries of its own. Meerkat, located in the Karoo region of South Africa, is an array of 64 radio dishes, each 13.5 meters in diameter. It is one of the most sensitive radio telescopes in the world, designed to observe the universe at frequencies from 580 MHz to 1015 MHz. And in February 2025, Meerkat sent a message to the world: South Africa has its own giants. Astronomers from the University of Cape Town, led by Dr. Jacinta Delhaize, discovered a new giant radio galaxy. It was named Inkathazo, meaning trouble in Xhosa and Zulu, and the name is entirely fitting. Inkathazo has plasma jets spanning 3.3 million light-years from end to end. That is more than 32 times the size of the Milky Way. It is about 1.44 billion light-years away, closer than Alcyoneus or Porphyrion, but still an astonishing cosmic distance. But what truly makes Inkathazo special and troublesome is what it defies. Most giant radio galaxies are found in relatively isolated regions of the universe, where plasma jets can extend without obstruction. That is the case for Alcyoneus and Porphyrion, which found voids in the cosmic web to project their influence. But Inkathazo lies at the centre of a galaxy cluster. It is surrounded by other galaxies, pulled by their gravity and impeded by hot intergalactic gas, an environment that, theoretically, is unfavourable for jet growth. Yet Inkathazo still grew to colossal size. This discovery gave us unique opportunity to study giant radio galaxies, Jacinta Del Hayes explained. These findings challenge existing models and show that we still don't understand much about the complex plasma physics happening in these extreme galaxies, and there is more strangeness. Unlike most giant radio galaxies with straight jets, one of Inkathazo's jets is bent. It does not stretch straight from end to end. It is warped, possibly due to interactions with its environment or the motion of the host galaxy. This unusual shape is raising new questions about how plasma jets interact with the intergalactic medium, and whether there are other physical mechanisms we do not yet understand that allow these structures to survive and grow in environments where, theoretically, they should not exist. Inkathazo was discovered as part of the MIGHTY survey, Meerkat International Gigahertz Tiered Extragalactic Exploration, one of the most advanced surveys of distant galaxies ever conducted. Researchers pointed Meerkat at a small patch of sky near the equator, about the size of 5 full moons, and in that small patch they found 3 giant radio galaxies at an astonishing rate. This suggests that giant radio galaxies may be far more common than we ever thought. They are not rare monsters, but maybe a common evolutionary phase of galaxies with active supermassive black holes. We simply did not have the tools to see them before. Inkathazo also has distinguishing characteristics compared to other giant radio galaxies. Its location in a galaxy cluster raises questions about the role of environmental interactions in the formation and evolution of these giant galaxies. Could it be that, in some cases, dense environments actually help plasma jets develop in ways we do not yet understand? Or is Inkathazo an exception, a monster that found a way to survive and thrive in an environment where, theoretically, it should not exist? The discovery was published in the monthly notices of the Royal Astronomical Society on January 17, 2025, and it underscores an important point. While LOFAR is exploring the northern sky with unprecedented detail, Meerkat is doing the same in the south. 2 telescopes, 2 hemispheres, together painting a complete picture of the radio universe. But perhaps the most important thing Inkathazo has proven is we still do not fully understand how black holes interact with their environments. We still do not have a complete theory of how plasma jets can extend so far in different environments under different conditions. Every time we think we've found the rule, the universe presents an exception, an Inkathazo, a trouble, challenging every assumption we hold. And perhaps that is the beauty of science. Not the final answers, but the new questions that each answer brings. We are living in a special moment in human history. Just recently, in January 2026, an event occurred that few noticed, but for those following astronomy, it was an unforgettable milestone. The Skamid telescope, in the arid desert of the Northern Cape, South Africa, achieved its first fringes. The first time 2 of its giant dishes worked together as a single entity. 2 15-meter dishes simultaneously observed a radio galaxy about 2.6 billion light-years away. The signals from the 2 dishes were combined with precision to a billionth of a second, creating an interference pattern, a fringe, proving that the entire system was working as a single telescope. This is the first real test showing all our systems are working together. And Skamid is alive as a scientific instrument, declared SKAO Director General Philip Diamond. Skamid now has 7 dish structures assembled on site, with 12 more dishes en route from China. When complete, it will comprise 197 dishes and will integrate the existing Meerkat telescope. But SCAMID is only half the story. On the other side of the world, in the Wajari-Yamaji region of Western Australia, one of the quietest radio sites on the planet, Scalo is being built. Not giant dishes, but a forest of 131,072 low antennas spread across a vast area. To date, about 70 antenna stations, each comprising 256 individual antennas, have been installed. In August 2025, the first 4 stations, a total of 1,024 antennas, completed their final verification testing, and they produced Scalo's first image. When complete, SKA will be 50 times more sensitive than any other radio telescope. It'll be able to survey the sky 10,000 times faster than before. LOFAR, the tool that discovered Alcyoneus, Porphyrion and TXS 0033 plus 252, has about 300 usable antennas. Scalo will have nearly 60,000 antennas in its densest central region. Scalo's antenna density will exceed LOFAR's by more than an order of magnitude. Let those numbers sink in. If LOFAR is an ear listening to the whispers of the universe, then SCA will be a million ears, placed at the most strategic locations on the planet, all listening together for the faintest signals the universe can send, and we have only just begun. SKA will open a completely new door into the universe. It will allow us to see radio galaxies farther, fainter, more ancient than anything we have ever seen. It will help us understand how galaxies evolve over cosmic time, how supermassive black holes interact with their environments, and perhaps even answer one of the deepest questions, whether we are alone in this universe. But for our story today, the story of the largest galaxies and giant radio structures, SKA may do even more. It will show us what we have been missing. Think about this. LOFAR found Alcyoneus, Porphyrion, TXS 0033, plus 252 and thousands of other giant radio galaxies just by scanning 15% of the northern sky. SKA will scan the entire sky with 50 times the sensitivity. It will find structures that LOFAR could not see, structures too faint, too distant, or lying in sky regions LOFAR never reached. And when it finds them, the question, what is the largest galaxy, will change once again. Perhaps the title will belong to a structure twice the size of TXS 0033 plus 252, or 3 times, or 10 times. We do not know, and that is what makes it most exciting. When you look up at the night sky, you see stars. But what you do not see, what only SKA can reveal, is a vast network of plasma, energy and magnetic fields, stretching tens of millions of light years, connecting galaxies in ways we never imagined. That is an invisible universe, but it is real, and we are about to see it for the first time. Perhaps what we have found so far is only the first pieces of a much larger picture, and that picture, when complete, may change everything we thought we knew about the universe. Now let everything slow down a little. You've travelled a long journey, from the Milky Way, your small home with 400 billion stars and 100,000 light years, to IC 1101, the old king with its halo stretching 6 million light years, then to Alcyoneus, the challenger of 2022 with 16.3 million light years, Porphyrion of 2024 with 23 million, and TXS 0033 plus 252 with 26 million. The numbers kept growing, kept reaching farther, kept surpassing every limit we ever thought possible. But now, come back to you. You're still lying there, perhaps in bed, perhaps in a chair, perhaps outside it is dark, or perhaps dawn is beginning to break. Wherever you are, whatever time it is, your body is still here, on this planet, in this galaxy, and your galaxy, the Milky Way, has a black hole at its centre. It is called Sagittarius A*, about 4 million solar masses, tiny compared to the black holes we've been talking about, but it is still there, right at the centre of everything you call home. Right now, Sagittarius A** is sleeping. It is not ejecting giant plasma jets. It is not creating structures spanning millions of light years. It simply exists, a silent mass in the darkness, holding your galaxy together. But what if it woke up? What if, at some distant future moment, a giant gas cloud fell into Sagittarius *? It would swallow that matter, and in the process, it would eject plasma jets. Those jets would race out from the center of the Milky Way, piercing through thousands of light years of space and begin their journey. And perhaps, millions of years later, those jets would create a structure that future astronomers, if any remain to observe, would call the largest galaxy. But you will not be there to see it. You will have been gone for millions of years. So why does any of this matter? Because you're living in a special moment. A moment when humanity can first see these structures. A moment when we, small creatures on a small planet, can sit back and wonder, who are we? Where are we? And what does all of this mean? You have seen that the question, what is the largest galaxy, has no single answer. You have seen that largest can mean the most stars or it can mean the longest. You have seen that what we think we know is often just a small part of the picture. You have seen that the universe always has ways to surprise us. And now, as this video draws to a close, I want you to carry one thing with you. Not a number, not a record, but a feeling. The feeling that this universe is larger than anything we can imagine. The feeling that what we know is only a drop in the ocean of the unknown. The feeling that even the most ordinary things, a small galaxy, a humble black hole, can produce extraordinary things when they're in the right place at the right time. And perhaps that is true for you too. You may feel small. You may feel unimportant. But you're here, at this moment in the history of the universe. You're seeing things your ancestors could never see. You're asking questions they could never ask. And that in some way makes you extraordinary. Now, let the numbers fade. Let the records dissolve. Let the questions hover in the air, not needing immediate answers. You're lying here. Your breath is slowing. Your body is relaxing. And outside, the universe is still turning, still expanding, still creating new things we've never seen. Perhaps the final question is not what is the largest galaxy, but how much more is waiting for us to discover? And the answer, my friend, is infinite as the night sky, as infinite as your dreams, as infinite as the universe itself. And now, let yourself sink into the silence. Let the stars tell their stories. Let the black holes whisper their secrets. Let the universe embrace you in its vastness. Because you're not just watching the universe, you're a part of it, and it is a part of you. Now, let everything settle. You have travelled a long journey. From your small home in the Milky Way to the old King IC 1101, then to the challengers, Alcyoneus, Porphyrion, TXS 0033 plus 252. The numbers kept growing, records kept breaking, and each time we thought we'd found the final answer. But perhaps the final answer is not a number. Perhaps the final answer is humility. Because the universe does not care about our titles. It does not hold competitions. It does not crown anyone. It simply exists, vast, complex, and full of surprises. And our task as small creatures trying to understand it is not to assign it titles, but to listen, to observe, and to let it teach us things we have never known. You have seen that largest can mean the most stars, or it can mean the longest. You have seen that what we think we know is often only a small part of the picture. You have seen that the universe always has ways to surprise us. And now, as this video ends, I want you to carry one thing with you. Not a number, not a record, but a feeling. The feeling that you're part of a story much larger than yourself. The feeling that the questions you ask today will be answered by future generations. The feeling that even in your smallness, you're contributing to humanity's greatest journey. The journey to understand the universe. Because you're not just watching the universe. You're part of it. And it is part of you. The atoms in your body were once inside stars that died long ago. The particles in your lungs travelled across millions of light years before reaching here. You're not separate from the universe. You're the universe becoming aware of itself, and perhaps that is enough to make you feel at peace. Now, let yourself sink into the silence. Let the questions hover. Let the universe embrace you. Thank you for joining me on this journey. As always, I would love to know where in the world you're listening from and what time it is where you are right now. Please share in the comments, and don't forget to subscribe to Space Lull to explore more wonders of the universe together. Sleep well, and always remember, the universe is still waiting for us.